Hi, my name is Jordan Stevens, and I'm doing my project 3 on the Statistical Process Control project. I'm going to start out with the problem description. The statistical process control is a widely used process in quality engineering to check if a certain product or process is in control, or there needs to be a check to see if there is a problem. So basically, is the process in control or out of control? This is the problem I chose from the list. This project wanted an interactive user face that prompts the user for a certain type of SBC. That means like a X-bar chart or a P chart or an R chart. After that, we have to specify what the required information in the series for the SBC would be, like sample size or UCL, which is the upper control limit. After this, the program wants us to give the sample data, and then finally they want us to give the relative solution data and plots based on the information that we have entered above. The reasoning of topic. The reason why I chose this problem is because the fact that I was doing this all summer, and I would like to reinforce these topics in case I do future work in this field. This project offers a good practice for remembering the SBC charts and their uses. This project will positively increase my skill base if I were to go into quality engineering, since these methods are so pivotal. I used other programs other than Excel, but I was basically doing almost exactly like this, what we're doing in this Excel program, which is entering data, checking if it's in control, and building SBC control charts for lower workers to use. Next, I'm going to go into my itemized specifications. These are all the deliverables that the project asked for. So if I were to choose the X-bar and R-bar type, it would require all of these in the solution space. So X-bar, R-bar, the UCL, LCL for both of them, and the plot of the statistical process control, and then all the other types. After this, my Excel program completed everything in the table below. My user form accounts for all the variables. I actually added a couple of additional features to the project to make it more applicable to a quality engineer. After I did this project, I found that it was wanting. I found that it needed a couple more things. Like, it asked for you to put a plot, but it never asked for you to actually enter new data into this said SBC chart, which I found kind of weird, because a quality engineer will need this SBC chart, but they'll also need to enter future data. So I actually built a user form that will enter new data in and check it in the SBC control. I really found this project really fun, but I also found it really difficult. Some of the ways I found it difficult were the first one was the highlighted text below, which is insert a command button that when clicked on displays a table that has many rows as the number of replications and as many columns as the sample size. So, sorry about that. So basically, it asks if it asks you for sample size and number of replications, it expects you to have a table where a user can input the data, and it will go to the Excel spreadsheet and they will use that data to find the solution. I believe when these projects were made, they could use a function called data grid view, which is widely used in other C# and C++ codes, but it's not actually used in VBA Excel. It's actually outdated by a lot of years, and I think that's what they wanted, which would have been super easy to do, but since it was outdated and irrelevant and I couldn't actually do it, this task was actually quite hard. I got around this problem by adding a bunch of text boxes linked to individual cells. Then I made the irrelevant text boxes invisible. I'll explain this later when I explain my Excel code. The second problem was the second major technical problem I had was putting the plots into a user form and then making the plot dynamic so I could enter new values. I got around this problem by using the image tool, which is a tool that is used in the user forms. I first recorded a macro to plot the chart, and then after putting that macro into my user form, I then converted the chart to a .gif file. Then I pasted the file into the image tool. And I also made a button that updates the image with new entry data, which makes it dynamic. This was quite hard too, I believe. Since I was using a chart that highlighted or had a range of certain values, I had to keep track of all these ranges and make sure that they were in check and I was actually adding the values that I wanted to the chart. Next, I'm going to go on to future research. For future research, I would love to be able to automatically add data files from like Access or other like programs. This would make it really easy to enter a lot of big data into my problem. I would also like to add run tests to the Excel file. A run test is basically stuff like the 7 rule, where if 7 entries are going in a positive direction or a negative direction and they don't switch that direction, then the process is likely out of control. And there's other rules like that for run tests for an SPC. That would add a greater degree of accuracy at whether the process is in control. I would also like to add some high-level statistical formulas as it relates to the z-score. A couple of the like the capability, you needed a z-score value, and it would have been a lot easier to make a z-score based on whether the problem was large or small. So now I'm going to go and open my file. I'm going to Engineering 430. So here's my file. It first opens up and asks you to choose the type of statistical control. So each one of these is a different type of problem. An X bar is where it has a certain measurable variable, like length or weight, and it will use samples and averages to figure out if a process is in control. A P chart is the number of defectives chart, basically. So basically, if you have a sample of 100, how many out of those 100 variables would have a defect in them? A C chart is used for whenever you're counting how many defects are on a single item. So like this is useful for like computers and like products that could have a lot of minute problems on there, or defects, and adding this control would monitor the amount of defects and check if the process was in control. And then finally, capability. Capability relates to all three of them. Capability is just the capability of the SPC covering the entire spread of the 6 sigma distance away from the mean. So I'm actually going to start off and I'm going to choose my X bar one first. I click choose. Now it will ask me for the sample size and it will ask me for the number of replications. This is pretty easy for to understand for the X bar chart. After I click that, this is really cool. This is the slide I was talking about with the first technical problem, where each one of these text boxes is individually linked to a cell in my Excel chart. So you can see here, it's right here, right? But I only want to display the correct number of text boxes so that the user doesn't enter in more information than they need. So this is where I built this. This is this is only the allotted amount, and if you saw the full user form, it would have a full grid right here if the problem were bigger. There's one drawback to this, and that's I can only have a certain size problem. I can't do this infinitely, so if I had a problem that was bigger than the user form text boxes, the amount of text boxes I used, then it wouldn't work. So then let's press calculate, and then once I press calculate, it will give me the X bar, the UCL and LCL, the upper control limit and the lower control limit for the X bar chart right here. It will give me R bar. Oh, this is a slight error in Excel. Whenever you have a text box and there's a number like 0.0 something, it will automatically put it in scientific notation, even if in the original form it's not in scientific notation. This is kind of annoying, so this value is actually 0.046, not 4.6. And then it will give the UCL and LCL of the R chart too. So then this is the other cool part. This is the additional material I added on. So this is my user form for my plots. So I have the X chart and the R chart for the statistical process control. Then if I want to add a new point, I use these 4 boxes right here, and I enter in my data since I already have entered in data right here. So then once I press the command button, it will automatically add this new point right here into my control. So like, let's say that I have a problem that is definitely out of control for both, right? It shows that this is definitely out of control in both graphs, and then I can do this infinitely amount of times, so I can check if a process is controlled or not by entering new data values. So this was the first one. So now I'm gonna click this activate GUI button. I'm just gonna go over to pchart and just check out all of them. This one asks for sample size, number of samples, and the confidence level. I put 99.74 because that translates to 3 in the z-score. If you do this, enter in the values, number of defectives per sample, calculate, it gives me my answer, and then I plot. For this one, I just entered the plot data right here. This is definitely out of control because I forgot to put the 100 samples. But yeah, so you can see that this is a right process for this. So then I will activate GUI again. C-chart's basically the same thing as P-chart. I can just click through it. It's basically almost the exact same thing. And it gives all the right data right here. This is also out of control because my sample size is wrong. That would be where I would enter sample size in the beginning and it would give me the right value. And then finally capability. Capability doesn't ask for a plot, so I won't do a plot. This asks for upper control limit and lower control limit. That's what capability needs. And then same for the number of locations, and then it gives me my relative values for my sigma, x bar, CP ratio, and CP index. Finally, I'm just going to show you some code that I used. I will go to the export plot, and I'll click it. As you can see, this uses a lot of As you can see, this uses a lot of code. Mainly the bulk of it is just the plot function. The real cool part is right here. This is me managing my new data entry values in. So when you click the command button, it will automatically update all the values and then replot the image, which is these 2 functions below it. So in conclusion, this was a really fun project. I really liked doing it, and it just reminded me of how much I've come since like freshman year, and how much I learned in my internship, that this problem, which would have seemed almost impossible to me freshman year, is actually seemed quite simple to me now, even though it involved a lot of code and a lot of memorization of VBA code and of how these problems worked. So in conclusion, I really like this project, and have a great Christmas, Professor Hom.